Hey, I'm Brains, and I'm your math tutor. Today, we're going to talk about trig functions. Don't forget to hit that like and subscribe button, and let's just jump into it. Trig functions are actually just ratios of the side lengths of a right triangle. The right triangle we'll use has an angle theta, a height y, a length x, and a hypotenuse r. Sine theta is defined as y over r. Cosine theta is defined as x over r, and tan theta is y over x. The three remaining functions are cosecant theta, which is 1 over sine theta, secant theta, which is 1 over cosine theta, and we have cotan theta, which is 1 over tan theta. Another way to think about the side lengths of a triangle is to label them with opposite and adjacent. With them labeled opposite and adjacent, we could use this acronym, SOHCAHTOA. In SOHCAHTOA, we have SOH, which is for sine, opposite over hypotenuse, CA, which is cosine, which is adjacent over hypotenuse, and TOA, which is tan for opposite over adjacent. Now that we have defined all the trig functions, we just need to remember one more important formula, the Pythagorean Theorem. You remember from class that you have a squared plus b squared is equal to c squared. It's the same formula. We're just going to rename it so that we have x squared plus y squared is equal to r squared. Now I hope you've been writing this down because we have one more thing left to cover, the unit circle. Okay, for the unit circle, we can think of it broken down into 4 quadrants. Quadrant 1, 2, 3, and 4. I'll label our axes x and y. If we quickly study the quadrants, we can see that in quadrant 1, x and y are both positive. In quadrant 2, x is negative and y is positive. In quadrant 3, both x and y are negative. And in quadrant 4, x is positive and y is negative. With that in mind, we can start defining some special angles. We know that a full unit circle is 360 degrees, or 2 pi. The special angles are pi over 6, pi over 4, and pi over 3. And then the multiples thereof afterwards. So here's the unit circle all filled out. Normally, you don't see the rectangles drawn on it, but I like to do it because you can show that each angle is connected in some way. All you have to do is follow the lines, and you'll see that the values are the same, and you just have to watch out for which sign it is. For example, you can see that pi over 4 and 5 pi over 4 are connected. It's just that 5 pi over 4 is in quadrant 3, so the values are negative. Okay, it's time for an example. Let's do all 6 trig functions of theta equal 7 pi over 6. First, we need to find 7 pi over 6 on our unit circle. 7 pi over 6 is in quadrant 3, so both sine and cosine are negative. 7 pi over 6 is connected to pi over 6. Cosine of 7 pi over 6 is negative root 3 over 2. Sine of 7 pi over 6 is equal to negative 1/2. And tan of 7 pi over 6 is equal to sine over cos, so 1 over root 3. Rationalize, so you get root 3 over 3. Secant is 1 over cosine, so we have negative 2 over root 3. When we rationalize, we get negative 2 root 3 over 3. Cosecant of 7 pi over 6 is 1 over sine of 7 pi over 6, so we'll get negative 2. Cotan is the same as 1 over tan, and since tan is 1 over root 3, we just get root 3. You can even use the unit circle to find angles that are negative or even greater than 2 pi. All you have to do is add or subtract 2 pi until you get an angle between 0 and 2 pi. So for example, we have negative 11 pi over 6. If we add 2 pi, we just get pi over 6. For 5 pi, we could subtract 2 pi twice, and we are just left over with pi. Our last example is about finding the remaining trig ratios, given that we know one of them, and we know which quadrants it's in. Okay, we're given that sine theta is equal to 3 over 5, and that it lies in quadrant 2. We learned from before that sine theta is y over r, so y is 3 and r is 5. So let's use Pythagorean theorem to find x. we've got x squared plus y squared is equal to r squared. So if we rearrange it, we have x squared is equal to r squared minus y squared. So x is equal to the square root of r squared minus y squared. We'll plug in our values. So we have x is equal to the square root of 25 minus 9, square root of 16. So we have plus or minus 4. We have two values, so now we have to find out which one we use. Because the quadrant is quadrant 2, x should be negative. So we're going to use the negative 4 value. Now we can fill out the rest of our values. Sine theta is 3 over 5. Cosine theta will be negative 4 over 5. And tan theta will be negative 3 over 4. Cosecant theta is 1 over sine theta, so we'll have 5 over 3. Secant theta is 1 over cosine theta, so we'll have negative 5 over 4. Last but not least, we'll have cotan theta, and cotan theta is just 1 over tan theta, so we'll have negative 4 over 3. And we're done. Hey everyone, that concludes today's video. Thanks for watching. If you have a topic you want me to cover, please let me know in the comments down below. Don't forget to check my Instagram for lots of awesome notes and some solved problems. Once again, I'm Brains, your math tutor. Drop a like and subscribe, and I'll see you in the next one.